Hello. I hope by this time you are really good at finding the sine and the tangent and the cosines of function. In this video, what I'm going to do is I'm going to teach you how to find the inverse. What I mean by that is how to find the angles whose sine or tangent or cosines are already given. And it's very, very easy. Okay, it will take us around 15 to 20 minutes to do that, of course, with examples and explanation. And I'm sure by the end of this lecture, you'll be able to very easily find the inverse functions. So let's get started. So this is how the natural science tables look like. Okay, and let's take some examples, and let me pull a post-it here, and let's take the similar example that we had taken while we were studying the process of finding the sine and the tangent and the cosine. Now if you remember, we had said that sine of 30 degree, right? If you try to find out sine of 30 degree here, this is natural sines. And if you remember, I told you to find sine of 30 degree, you look at this column, this is 30 degree 0 minutes, and that is 0.5000, right? This is what how I said. And therefore, when we say finding inverse, what this actually means that therefore 30 degree is equal to sine inverse, this is how it is written, sine inverse of 0.5000. Okay. Now, what is this all about? So, for example, suppose if I give you something like this, that sine of theta is equal to 0.5000, and then I ask you what this theta is, then you will write therefore theta is equal to sine inverse of 0.5000. So what you will in principle do is, in this region, now you will try to find out a number which is as close to 0.5000 as possible, and then look in the corresponding row and the column for degrees and the minutes respectively. So in this case, say for example, we want to find out sine inverse of 0.5000, right? So here in this area, we'll start looking at 0.5000. And of course, now I know that 0.5000 is sitting right here. And what I will do next is that look in this row and look in this column. So when I look in the row, I get theta to be equal to, we know this corresponding to 30 degree and 0 minutes, right? 0 minutes, right? And there could be, another interesting way also. And people might say, well, you know what, this is, you said that try to look at the number which is as close to 0.5000 as possible. There's another way to do it. Please remember that we are going to get approximate answer. Now here, fortunately, we have exactly 0.5000. Okay, so there's no issue as such. But let me take, another example which will clarify the point that I am trying to make. So now suppose I want to find out sine inverse, say theta is equal to sine inverse of, say, let me take number 0.2907. Okay, again start looking at a number which is as close to 0.2907 as possible, and when I look at it, see, this is where I see 2907, right? And so what I will look at is this corresponding row here. I will look at this particular angle and then this particular minute. So what is the answer that I get. Theta is equal to, this is turning out to be 16 degree and 54 minutes. Okay, so that's the angle whose sine is 0.2907. Now let me give another example. Okay, now suppose had I asked you find out sine inverse of say I don't know, I'm just making up some number now, say 0.2913, say for example. Okay, in this case what will happen is that we'll try to find out a number which is as close to 0.2913, I mean as close to 0.2913 as possible, and what I find is that it's 2907, which is very close to 0.2913, but it is not exactly 0.2913, it's 2907. So of course I will look at this corresponding degree, that turns out to be 16 degree. But now look what I'm going to do. This, remember, in sine and tan we always add the mean difference, right? So what we shall do here is, now in 0.2907, what number should I add so that I get 0.2913? And if I add 6 to 0.2907, here is 6, okay? If I add 6 to 2907, I get 2913. And so the corresponding minute in this particular is now 2, and so therefore this 54 plus 2, so I get 56 minutes. That is the answer. So theta is equal to 16 degree 56 minutes. And now I would like to draw your attention to the previous example that I had taken, that theta is equal to sine inverse of 0.5000 here, right? Now see, please understand, here exactly we are getting 0.5000. We would like to have that number only, but we can go to 30 degree, very close to 30 degree in another way also. Say for example, here if you see, you have 4985, right? 4985. So when you say 4985, the corresponding degree or angle is 29 degree. Okay, and now if I add actually 13 to it, to 4985, so what do I get? 8, and 8 plus 1, 9, and then you have got 9 here, and this is also 4998. So basically, it's turning out to be sine inverse of 0.4998, which is very close to 0.5. So angle could be 29 degree. And what is this going to be? Have a look at this. 54 plus 5, 54 plus 5, because this is corresponding to 5 minutes. So this is 54 plus 5, so it's turning out to be then 29 degree 59 minutes, okay, which is approximately again 30 degree. Okay, you might have such situations where you might not get the exact angle, but you'll reach to as close to the angle as possible. But of course, please, this was with the purpose of example that I've given you. Fortunately, in this particular example, we are getting exactly 0.50000. So of course, our angle is 30 degree, and the other way is 29 degree 59 minutes, which is also approximately 30 degree. Remember, these tables are going to give you approximate value. So let's take couple of examples more, and then what you could do is you could try to pause this video and then try to figure out the examples. So I mean the angles. So say for example, let me take one example here. Theta is equal to say sine inverse of I don't know, I'm just taking up some number here. If I take some number here, say 0.757547. Okay, so tell me what is the angle? Well, it's easy, right? So in this region now you will try to see 0.7547, and you see here you're seeing this 0.7547, and it is corresponding to 49 degree and 0 minutes, which is of course 49 degree. Let me take another example. Say theta is equal to uh, sine inverse of 0.9136, 0.9136. So you're trying to go to as close to 9136 as possible. And when I do that, you can pause this and try to figure out this. Okay, I hope you got this. So you're here, you have 9135. So this is corresponding to 66 degrees and 66 degree, and of course this is 9135. We want 9136, so I will add 1 here, and this is corresponding to now 1 minute. So 66 degree, because this is 0 here and this is turning out to be 1 here, so it is 66 degree and 1 minute. That is another example. Let's take one more example. Try to find out theta of sine inverse of let's say 0.9706. So you'll try to reach as close to this number 9706 as possible. Pause it and try to find out that angle. Okay, I hope you got that. And 0.9706. So I'll say 9703, which is corresponding to now 76 degree. And of course, this 0 minute, but this is not 9706, this is 9703. So I'll be adding 3 to it, right? So that will make it 9706. And the corresponding minute here is 4 minute. So it is 76 degree, 4 minute. So this is one example. Let's take one more example. Theta is equal to say sine inverse of 0.9885. Okay, 0.9885. So this is equal to 0.9885. I see it here. So 0.9885. So that makes it 81 degree, right? Because this is 81 degree here, and the corresponding minute is 18 minute. Okay. Now here, please understand, if you add 0, then this is going to become 19 minutes as well. Okay. But please remember, you get to this first, and whether it should be 81 degree or 18 minutes, or 81 degree, you add 0 to it, and then it is coming out to be 19 minutes. Both in principle are going to be approximately correct answers only, but you take the lower one, right? So which one should you take, 81 degree 18 minutes or 81 degree 19 minutes? So you take the lower one, so 81 degree and 18 minutes and not 19 minutes. All right, so this is the example. Let me take one more last example, and I hope you'll be able to find that out. And let's see, theta is equal to say sine inverse of I don't know, I'm making up some number, 0.44 say 18. Okay, so this will be like 4418. Where is a number which is close to 4418? So I'm seeing here 4415. So the corresponding degree here is 24 degree, and the minute here is 18, but it's 4415. So I need to add 3 to it, right, to make it 4418. So in the same line, I will go here and see, I see 3 here. If I add 3, then it becomes 4418, right? So this is 18 minutes here, and in this is 1 minute here, so it becomes 19 minutes, because I'm going to add. Remember, the mean difference is to be added, and the minutes are also going to be added, right? So this is how the natural sines inverse function finding works. Remember, the process of finding the tangent is exactly similar. So now let me pull out the tangent tables, and let's take similar examples here also. Let me pause a bit and let me pull out the tangent table. So this is how the tangent tables look like, and the process is exactly similar to the way we found out the inverse sine inverse. Because here also, remember, the mean difference is to be added. So let's take a few examples here, and if you've understood the process of finding the inverse, sine inverse, then this should be also very easy. So suppose, for example, if I give you find out theta is equal to tan inverse of say 0.2679. Now remember, you are always trying to find out a number which is as close to this number or slightly less than this number, because so that you can add mean difference, right? So for example, well, this is very easy. So you can easily see here theta is 0.2679 is located right here. So it is turning out to be 15 degree and 0 minutes. Now let me take an example. So suppose, for example, if I second example, theta is equal to tan inverse of say, if I give you 0. I don't know, uh, say 2889. So you will try to find out a number which is as close to 0.2889 or slightly less than 0.2889, right? So when I look at the tables here, I find that here is a number which is 2886, which is very close to 2889, and I can add 3 to it in the same row. I can add 3 to it, and it is going to become 2889. So now I look at the corresponding row here. It gives me 16 degree, and here the corresponding angle, sorry, the minutes is turning out to be 6, and in this column the corresponding minute is turning out to be 1. So 6 plus 1 is making it 7, and this 2886 plus 3 is making it 2889. And so remember, you always try to find out a number which is exactly this or slightly less than this, and then you add the mean difference, and of course you add the minutes as well. Let us take another example. So say if I ask you to find out tan inverse of well, let me just try to say 0.7137, say for example. So you'll try to find out now a number which is exactly 7137, which probably you might not find, but then you'll try to find a number which is as close to 7137 as possible and slightly less than 7137. So when you see this, you will find that let us try to find out 7137. Oh, there I get 7133. That number is very close to 7137. So the corresponding angle turns out to be 35 degree already, and it's 7133. So I need to add 4 to it, right, to make it 7137. So this corresponding minute is turning out to be 30 minute, and this corresponding is turning out to be 1. So 30 plus 1, 31 minutes. So that's how you get the tan inverse of 0.7137. Let's take a couple of examples more, and you try to pause the video and try to get the answer. So this is my fourth example. Say theta is equal to, try to find out tan inverse of well, this all is, remember, all this is like 1.00. So this, all these angles are kind of 1.0035, 1.0070, and so on and so forth. Just remember that. Okay, so tan inverse of say well, 1.0355. Okay, so it's very easy. You can see this here directly, and it is 46 degree. Okay, so let me take one more example here on this side only, and here it goes. So say find out theta is equal to tan inverse of 0.55, say 70, 0.5570 tan inverse of. So I start looking at a number which is close to this. So I see here 5566. It's very close, right? Because then I'll just add 4 to it to make it 5570. So the angle turns out to be 29 degree, and this corresponding minute is 6 here, and this corresponding minute, wait a minute, I hope I've taken the same line. Yeah, is 1. So 6 plus 1, 7 minutes, right? So remember, in the sine and the tangent cases, you always try to find out a number which is exactly this or slightly less than the given number, and then you added the mean difference, and of course you added the minutes to it. Now let's have a look at the cosine inverse. I mean, let's see what happens there. So I am going to now pull the cosine tables. Let me pull that. So this is how the cosine tables look like. Now, please understand, if you recall that in case of cosines, we always try to subtract the mean difference. And when we're finding out inverses of sine and we always try to find a number slightly less, and then we added the mean difference. Now here in this case, because the mean difference is to be subtracted, here you will try to find out slightly greater number, and I'll just clarify that with the help of the example here. Okay, so say for example, first let's take a very easy one. Theta is equal to say cos inverse of say point I don't know, 9608, say for example 9608, right? So this is an easy one. So you have this here 9608, so it is very clearly 16 degree, and in this column you will very easily see that it is 6 minutes. So 16 degrees 6 minutes. This was easy, right? Now let's take similar example, but cos inverse of, say for example, I ask you to find out 0.9607. Now this is interesting. Now you see, now what you will do in case of sine and tan, you always try to find out a number which is given here or slightly less than the number which has been given. Now here, because the mean difference is to be subtracted, what you will do is you will try to find out a number which is same as either this given here or slightly greater than this. So now what happens is here, number which is slightly greater than 0.9607 or 9607 is 9608. And we have seen the previous example, the angle is 16 degrees 6 minutes, but now it is not 9608, it is 9607. So if you come in the same row, here is a mean difference out here. If I subtract 1, because remember mean difference is to be subtracted, if I subtract 1 from 9608, I get 9607. Okay, so what I will get is 16 degree. Remember, you're going to subtract the mean difference, but please remember you're going to add the minute. Okay, so you're going to add the minute. So it is going to become 16 degree and 6 plus 1, 7 minutes. This is where the subtle difference between finding the inverse in case of cosine and sine and tan lies. Let me take another example. I hope this is very clear to you. So here you're going to try and find out a number which is either the one which is given or slightly greater than greater than this number which has been given. So say for example, if I ask you to find out theta is equal to say cos inverse of I don't know, maybe 0.8837, say for example. So what will that turn out to be? Cos inverse of 0.8837. So I can see here 8838, and the corresponding angle is 27 degree. Oh, sorry, 27 degree. Okay, and the minutes here are 54 minutes, but this is 8838. I want 8837. So I'll subtract 1 from here. So then 8838 minus 1 will make it 8837, right? So, and the minutes are going to be added. So 54 minutes and this is 1 minute. So 54 plus 1, 55. So it's going to become 27 degree 55 minutes, right? Let's take, couple of examples more so that we are very clear about the process of finding out the inverse. Say fourth example I'm taking is theta is equal to say cos inverse of let's say 0.7020. Okay, so what I will do is I'll just try to find out close number. If I get this, good for me. If I don't, I'll try to find out a number which is as close to this number as possible or slightly greater than this number. So that is going to be, say, I'm seeing this here 0.7022, and so the corresponding angle is 45 degree already, and but the minutes are going to change because this is not 7020, 7022. The minute is 24, and I'll subtract 2 from this. The corresponding minute is 1. So 24 plus 1, 25. So 25 minutes. So you get, so you subtract the mean difference but add the minutes, right? So let's take one more final example. Say for example, theta is equal to tan inverse of 0.6291. So what is, pause the video, try to find out the answer, and it's going to be say 6293, and then this is 2. If I subtract 2, it becomes 6291. So what is it? 51 degree, and this is like 1 minute. Okay, 1 minute. Right. So I hope you know the process to find out the inverse is also very clear to you. It's very easy, right? And if you are able to master this, which I don't think is difficult to master, then you have already got a hand on the first tool to do physics. We learned how to find log and the antilog. We solved plenty of sums there. Then we find out how to find the sine and cosine and tangent of angles, and we now learned how to find out the inverses, right? And I hope you're confident about finding. If you are confused a little bit, I would recommend that watch the videos all over again and get a handle over it, and you have learned the first tools which will be used to solve the complicated multiplications and divisions. Okay, great. So now we are ready to learn the second tool, and I shall see you in the next videos. Thank you.